managed to educate. Freaking love mushrooms. So when you go show up to the event that you sign up for, you're taking someone else's spot, and it also makes the people who are donating their time and their efforts feel bad, and we don't want anybody to feel bad. So if you sign up, show up, please. We have a few volunteer spots that are open and that are in need of people. Our fall show is our biggest event, and for the last few years, it has rested on one person in particular, Janet. She needs help. There's a ton of volunteers involved. So if you volunteer, I'm not taking anything away from you, but she is like the mega brain behind the whole event. And so we are trying to make it a more committee-oriented, less intense situation for her. So if you want to volunteer for the fall show, the committee is going to start meeting. We would love your help. There are plenty of areas, even if you just have a couple of hours to give, that we could use some assistance. Let's see. Our 75th anniversary celebration. So you might have seen things going out. It's going to be July 14th at Kelly Ford Park. We are doing a small version of what is an international mushroom art scavenger hunt called Game of Shrooms. We're doing a small version at Kelly Ford Park just for our members. But an art scavenger hunt needs art. So we are doing craft sessions. If you love this amazing headband, you can join us. You can make one for yourself. You can make one to hide in the forest. So if you can participate, great. If you are just an artist or a crafter and you have something, maybe it's not, your favorite thing and you'd be willing to part with it, we're taking donations. So mushroom art is the only requirement. We do have some local artists who have agreed to donate. So Mike Bennett, I don't know if you are familiar with his stuff, but he's rad. He said he'd give us some stuff. So hopefully that lures more people into joining that event. And there will be food. So let's see. So yes, if you want to volunteer for that, let me know as well. And let's see. We've got field trips coming up. So those are announced and you kind of sign up. It's our weighted lottery system. If you want to help organize field trips, that's another key area that we could use some help. So I think that's kind of it for me. I'm going to pass this on over to our MicroBlitz team. Kayla and Kat, and they'll let you know what's going on with the microflora project.
Maybe looking at my phone list. Sorry. So this coming weekend on the 19th, we have a microblitz at Downey State Recreation Area in Portland. And that's kind of Troutdale area. And so for that, we're going to be arriving at 9:30 a.m. till 12:30. We're going to go out for about an hour and a half, 2 hours, collect everything that we can find, and we're going to document it and put it on iNaturalist. So before you come to the event, make sure that you have iNaturalist added onto your phone. We're going to meet in the lower parking area. There is a parking permit. There's a $5 fee. You can pay that when you park. So, yeah, like I said, we'll reconvene after an hour and a half, 2 hours. I will have a microscope on site as well to see any spores or anything, and like do a demonstration. After that, we'll clean up and we'll kind of go through and ID what mushrooms we did find. If there's anything that is especially interesting, we will be sending it off towards the email. Yes, the other one though. Yeah, it went pretty good. It was a little bit early. Yeah. Here, but yeah, some people come along there. Pretty good. It rained a little bit. after the event, we'll probably yeah, it can be as many people.
Hi everybody, I'm Brett. I'm one of the coordinators for the myco camps that we run. I just wanted to give you guys a recap of our spring camp. And I'm not seeing, is anybody out in the audience who went to spring camp? A couple of people here. Great. So if you're here and you didn't make it to camp, we do have another camp coming up in fall. It should be around the first week of November, maybe the last week of October. Depending on how things are looking, sometimes we might cover shit before we send anything out. But the camps are a really great time. We're able to get about 100 people out to be let out to look for whatever we can find, document species, hopefully find edible things if that's what you're out there for. That's usually what I'm looking for. We found some morels in the Deschutes this last weekend. About 60 different species of mushrooms were found and identified. Alan was out there with us, which was really great. He gave the presentation he's giving here tonight, so that's probably why we don't have very many campers here. That's what's going on. But if you want to be a part of that, keep your eyes open on your emails. In the next few months, we'll have more information about our fall camp coming up. But we do fall and spring every year. If you have any questions at the end of the talks, I'll be sticking around tonight. You can come by and ask. Otherwise, Kim, I think. Yep. Thank you.
Thanks, Brent. Yeah, big thanks to Brent. It's a lot to put on the camps, and it's always one of our most popular things. So kudos to Brent and the team for pulling all that together. I guess, how many people saw the shout out for today's meeting that came out on the web or in mail? Okay, good. I would encourage you to go back and read that because we're now in the season of picking. And so I wrote a little blurb on the permits and where you can and can't pick, and also on edibility. So go ahead and look at those links. Not just one thing of being able to say, here you can pick, here you can't. It is probably the most convoluted thing that I've ever seen. If anybody here can attest to that, of knowing where you can, can't pick, how much you can pick, when you can pick, if you need a permit, if you don't need a permit. Every agency seems to be a little bit different. So I definitely encourage you to go and click on those links because there's some areas that are just closed that are really nice, like the Columbia Gorge, but we're not allowed to pick out there. But there's lots and lots of places that you can pick. And also, I really do encourage you guys, who's new to picking here? Okay, one tip I was told by someone who worked at the Poison Center, if you're going to eat a mushroom you're not used to or you're really not very familiar with, eat a small bit initially, because even though it may say edible, it is edible for some or most. We've had members that have developed allergies to things like chanterelles and morels. Those members who be sick by them while other people need to fine. And the member that used to work for the Poison Control Center says, always eat a small bit, but always leave a bit in your fridge so that when you get sick, if you're a person who's going to get sick, that they don't have to go through your vomit to look for spores, to determine what poisoned you. And that's true. That was her job, is to look through the vomit, so to speak. So if you do feel unwell, this is the best thing to do, is bring in to the doctor. And we can call Poison Control Center. So I encourage you to go read that stuff. Another announcement that we're happy to make is kind of two-part. We have a member here, Julie Wheeler, who is our artist extraordinaire tonight. And I was reading along and found out a couple of weeks ago that she was nominated, or a
show that she was in was nominated for an Emmy. Through OPV Arts Week, yes? Local event. So I will work to get that up on our Facebook page, so you can all take a look at that. We just want to say congratulations and hope, good luck on the nomination on that one. And also, in talking with Julie, we had someone that we wanted to get here. The speaker fee was a tad high at $15,000. But through luck and through everybody working and really just Julie's connections, OMSI is going to be premiering Merlin Sheldrake's movie, The Web of Life. And this is going to be on September 11th, 2024. And it's not going to be on their website for a few months. They're going to advertise that probably a couple of months in advance. But you guys get the inside scoop. It's not just going to be here for the premiere, but for a couple months after that. So again, thank you, Julie, for your connections. And we're all looking forward to that one. All right. I think that's all for the announcements. Want to say a big thank you to our speaker tonight. Not only was he at the camp and took probably 3 or way more days in being very generous with his time and knowledge, but also for coming back and sharing a talk that I think is going to be fascinating to those of you who couldn't make the camp. Alan's a mycologist. He specializes in DNA barcoding, field photography, fungal microscopy, identification, you name it, he seems to have done it. He's been doing this for more than 2 decades and has photographed more than 2,500 species of fungi. He leads forays all over North America, including Mexico. He's been studying fungal diversity there as well, and for 15 years, and is fluently bilingual. So that's great. Any Spanish speakers here? I guess we can speak in Spanish as well. He's always such a great person to have around with his identification skills. He's been teaching many people over the years how to extract and amplify DNA of their mushroom finds. What have you uploaded? More than 700 of your own fungal DNA sequences to GenBank, co-authored several scientific papers and publications, new species of bioluminescent mycena and silici. Let's see, pictures. Wow, you've identified over 300,000 fungi on websites such as iNaturalist, Mushroom Observer, various Facebook groups. And with that, let's welcome our speaker.
Awesome, thank you. That one worked out? Cool, thanks. And let me just grab this stuff here. Okay, I wanted to say a little bit about the spring mushroom camp, because that was really cool, and that's the reason I'm up here. And so I went and looked on iNaturalist to see what we found. And so this is what we found on iNaturalist for spring mushroom camps, so 37 species and 61 observations. But I know a bunch of you have photos that you took there that have not been uploaded yet. So definitely upload your pictures to iNaturalist, and we'll get those on there. Also, I made some Melzer's reagent to give away. So Melzer's reagent is a microscopy stain, and it's very hard to get because it's illegal. It has the controlled substance chlorohydrate. So if anyone needs any Melzer's reagent, just let me know. You just need to find like a bottle, or we'll find some kind of dropper or something to put it in. But I brought some of that. Also, there's going to be this psychedelic convergence coming up, so I'll be back for that, leading ultraviolet forays, ultraviolet night forays, and give a psilocybin talk there. And so this is a psychedelics event that's hosted by the mycology community. So that is pretty cool, and that's coming up like June 15th. So I gave a talk on luminescent and fluorescent mushrooms at the OMS Spring Camp, and then today I added about 60 new pictures. So if you saw the talk at spring camp, you won't be too bored. There's a whole bunch of new stuff in here. And so there are 3 different kinds of glowing things. There are luminescent or bioluminescent things, and those things glow in complete darkness, so they make their own light. And then you have fluorescent things, and those things, you shine an ultraviolet light on them, and then they light up visible light. And then phosphorescent means that you shine light on it, and then it keeps glowing afterwards. So there are no phosphorescent mushrooms, but you get like phosphorescent t-shirts and stickers and things like that, and rocks. So if you shine an ultraviolet light around, you'll often see phosphorescent rocks that keep glowing for a few seconds. So this is what fluorescent mushroom looks like. This is some Bovista from Telluride. And with fluorescence, you get all sorts of different colors, just about every color in the rainbow. So you shine the invisible ultraviolet light on it, and then it excites the molecules in there and gives you all sorts of different colors. A really fun thing to do is to run your ultraviolet light over the table at the fungus fair, and then you can see what lights up. And about 10% of things light up really well. You want to, is that one better?
Yeah, they're saying can't hear.
Yeah, that sounds right.
Testing, testing.
Yeah, that's definitely better. So the bioluminescent things, they glow in complete darkness. And bioluminescent mushrooms are much more rare than fluorescent mushrooms. Here is some armillaria, so that's honey mushrooms. And that is one that's really common here in Oregon. And so what I like to do is just take the same picture with and without light so you can see which parts are glowing. And you can see that just some parts of this are colonized, and the division there is like that black line there. And then Omphaliotis olivacens, probably endemic to California, maybe a little bit into Southern Oregon. But that's the jack-o'-lantern mushroom, so that one's pretty poisonous. And that is one of the largest bioluminescent mushrooms. And all bioluminescent mushrooms glow the same color, and that's a shade of green, about 535 nanometers. Most common one that you grow is Panella stypticus. And so this is Panella stypticus on supplemented sawdust. And somebody gave me a bag of this, and I just left it in the bag, and it was glowing for about 18 months. And then here's some that I found out in Michigan. And you know, the reason a lot of these photos look this cool is I use a technique called focus stacking. So with this one, you know, I took 40 pictures really fast and then combined them later with a software called Helicon. And then this one is also 40 pictures, but each one was a 30-second exposure. But using focus stacking, I can open the aperture all the way, which makes it so I can capture a whole lot of light and then get enough depth of field to be able to see, you know, all of the mushrooms at once. So I'll show you really quick how that works. I take all these pictures with usually a Nikon Z7 or an Olympus. But if you're trying to photograph bioluminescent mushrooms, you definitely want to use a full frame sensor for the low noise. And so something like a Nikon Z6 would be perfect. So I load them all into Lightroom. And then I select the mushrooms that I want in Lightroom and put those over in Helicon. And so this is what Helicon looks like. And I have 38 images loaded in here. And now you can just see the image just assemble on the screen. And you get really good resolution. I guess I don't have my mouse here, so I can't zoom in. But you get really amazing resolution and as much depth of field as you could possibly want. So these days, I use focus stacking on almost all of my mushroom photos. And if I'm not going to focus stack, then I just use my cell phone. And then here, I just stood still for half a second. And they say that the Panella stypticus on the East Coast glows in the dark, and on the West Coast, it does not. But here are some that I found on the West Coast, and it's glowing pretty well. So that's a good bioluminescent mushroom that you'll see here in Oregon. Another one that's pretty common in Oregon is Mycena rorida. And this one is growing on a tan oak acorn. And the mushroom does not glow at all. but the mycelium is glowing. So you can see like this mycelium here is glowing pretty well. And I took this picture at Soma Camp, which was like the California version of the Oregon Spring Mushroom Camp. It's even at like a Christian retreat center, just like this one. But this one, I just went into the bathroom and closed the door, and it was still way too bright. So I put a towel under the door like a stoner, and there was still some light coming around. So that's why it's kind of all lit up. But it was dark enough that I could capture the glowing mycelium as well. But this one's super slimy. You can see the layer of slime there on the stem, and pretty common, especially on the coast. And then this is a petri dish that has armillaria, so it's honey mushrooms, and honey mushrooms make those crazy rhizomorphs, like black shoelaces that you see, but on petri dish, they also make these really scary looking tentacles. And then wherever they kind of exit the agar, it glows. Another one that's really common in Oregon is Mycena hematopus, and this one just barely glows at all. It's mostly the mycelium and the stem base, but also where the mushroom gets bit by insects, it'll glow. And so this is Mycena hematopus glowing. And this is kind of what you see a lot of times when you find a lot of the glowing mycenas in Oregon. When I go to like Mexico or South America, sometimes the whole forest is lighting up, or a lot of places in Asia are like that. Here's one I found in Florida, and this one doesn't have a name yet, but the mushroom does not glow at all, but the mycelium glows really well. And here's a muscadine grape leaf with this rhizomorphic mycelium on it, and so that looks really cool. And so to find these things, I just turn off all the lights and walk through the forest, and it's some of the most dangerous mushroom hunting you can do, but that makes it really fun. This is a mycena that I found in Ecuador. And so this one was glowing really brightly. And then this one is Mycena lumina. And when I found this, this is in Oaxaca. When I found it, it didn't have a name. And my friends worked on it, and now we've named it Mycena lumina. So it looks like that. So it's a pretty bright one. Here's another one, Mycena lux follicula. And this one's kind of cool because the caps glow, the stems glow, and the mycelium glows, but the stems glow really bright. So I see this one only in Veracruz, Mexico. And when I'm walking at night through the forest, the stems look like these bright vertical lines that are glowing. One of my favorite ones is Mycena globulispera, and this one was recently described from Brazil, but the people who named it did not realize that it glows in the dark. But it's one of the coolest ones because the gill edges light up really bright, and then a little bit in the stem bases. But this one's actually really dim, so you can just barely see with your eye, if it's really well adjusted to the dark, that this one is glowing. So this picture here was a 40-minute exposure. So I just opened up the shutter and went to bed. And after 40 minutes, the camera ran out of batteries and saved this picture. Mycena fulguris, another one from Veracruz, and only the stem glows on this one. And then Mycena nebula is the first bioluminescent mushroom that I saw. This one only grows on liquid amber tree trunks in Veracruz, and looks like this. And we decided to name it Mycena nebula because at night there can be thousands of these on a tree that can kind of look like a nebula of stars from a distance. And then Mycena stylobates is kind of cool looking, but it doesn't glow at all, but the mycelium glows. So this is a beech leaf, and you can see the parts of the leaf that are lighter in color are the parts that are glowing. This one has not been named yet, but when it does get named, it'll probably be Mycena lux minor. And this one, it's super tiny, just a couple millimeters across, and this is a liquid amber seed pod here. And so this one, the primordia, glow pretty brightly. And then this is the brightest mushroom I've seen. This one is Mycena perlae. And Mycena perlae, I've seen it in Hidalgo, Veracruz, and Oaxaca. So the southeastern cloud forests of Mexico is where it's found. And this one is super bright, but only the cap glows. So that's what it looks like. And I found it in 2013. I was camping out with a friend, and I told him I was going to go look for glowing mushrooms, and he just laughed at me and just kept sitting around the campfire. But I started walking, and after about 20 feet, I stepped in a big puddle, and I was like, yeah, this was a really bad idea. But I kept walking, and after about 100 meters, I saw a whole bunch of these. And these are really bright. In fact, a really fun thing to do with them is just take a cap and throw it at night, and it looks like a shooting star. So these are bright enough you could like read a book with them. Another one is Mycena guzmanii. This is another one that was recently named, really common in the cloud forests of Veracruz. And the mushroom glows a little bit, but the leaves glow a whole lot more. And this one doesn't have a name yet. This is from southwestern Mexico. And this one I found, it was growing like 12 feet above the ground over a creek. So it was pretty dangerous to get it, but it was totally worth it. Here's one from Ecuador that doesn't have, Ecuador doesn't have a name yet. And this one was kind of funny because someone handed me this stick and thought they looked cool. And I'm like, okay, yeah, these are cool, but I'll just photograph them when I set my camera up. So I carried it around for like 15 minutes and finally found something else to photograph. And then turns out that the thing I was carrying around for all that time was glowing in the dark. And this one is mostly the stems that glow. And this one's the most mysterious one because I have no idea what it is, but it's kind of like a glowing bottle brush. And this one was from the maple forest in Jalisco, Mexico. So Mexico used to be covered in maple, and then after the Ice Age, most of the maples died out, but there's just a couple pockets of maple in Mexico, and those are really special places that have really good biodiversity. So bioluminescent mushrooms are pretty difficult to photograph because they're so dim. So you kind of need a long exposure. And if it's a pretty bright species, then your cell phone on night mode will do a pretty good job. But usually I set up a camera and a tripod. And it's really important that there's no other light. So if the moon is in the sky, then everything in the forest looks like it's glowing, and you can't really tell what's actually glowing or not. So I either wait for the moon to set or go out before the moon rises, or wait for a new moon. And then if there's a city nearby, it has to be a clear night, because if it's a clear night, the lights from the city will just go straight off into space, where if there's any clouds, then the light will bounce back down on you. But I use this app, Sun Locator Light, and it's just a free little app that tells you when the moon is going to be there. And it's also kind of cool when I'm camping because it'll tell me like exactly where the sun's going to be at any time of the day. So I can like tell like the sun's going to peek over this rock at exactly 11:30. And sure enough, like 11:31, the sun hits me in the face. It's a really good idea to find like a nice place to walk. And ideally, it's really good to be on a paved trail so you can like tell when you're starting to walk off the trail. So you don't just like walk over a cliff or into a river or something, which kind of happens all the time. But and then a lot of people use these red lights at night. But I think what works a lot better is just a super dim white light. So once your eyes are adjusted to the dark, if you just have a really, really dim white light, then it does not destroy your night vision. One thing that works good is just the screen on your cell phone, because they don't make flashlights that are dim enough for that. And also wearing glasses is a really good idea because the sticks like to poke you in the eye. And also just if you wear prescription glasses, it makes it a little bit sharper so you can see glowing things from a little bit further away. So it's usually like a really long exposure, and how long it is really depends on how bright the mushroom is, because some of them are like orders of magnitude brighter than others. But usually what I'll do is take a 30-second shot at ISO 200,000. So the camera is super sensitive, but super noisy. And that just lets me gauge like how bright it is and how long of exposure I need. And then I do the actual good shot. I turn the ISO down to like more like 800 and do like a 2 or 3 minute exposure. or these days usually focus stacking and combine a bunch of 30-second exposures. Another thing you can do is just collect every mycena and put it in a tackle box, and then go into a really dark place or wait for the sun to go down, and then just take a picture of your tackle box and see which compartments are glowing. So usually if I have like 20 mycena collections, like 2 or 3 of the compartments will be glowing. It's also, now we'll talk about fluorescent stuff. And you can see with fluorescence, you get a lot more different colors. So this is a picture that I took in Michigan recently, a Coptis trifolia. And it's glowing bright yellow only in the places that the bugs, the bugs bit the leaf. And so this super bright yellow fluorescent thing is a chemical called berberine. And it's really common around here in Oregon grape roots. So if you take an Oregon grape and rip out the roots, and then you just take the root, you can like paint on your face or paint on yourself with the berberine. And then under a black light, it's really bright. And there's just so many different plants that look awesome in ultraviolet light. So it's really fun to walk around. But this is something from the pineapple family. And I like to take the same picture in white light and ultraviolet light so I can see the difference. And cell phones work really good for fluorescent photography. So this is just a cell phone shot. But for the bioluminescent photography, it's a good idea to have a full frame, pretty high-end camera. But for fluorescent photography, because the black lights that we use are so bright, then you can get away with a cell phone and actually take some spectacular black light photos with the cell phone. This is a palm frond from Ecuador. And here is a weevil from Brazil. This one's just glowing super bright in the black light. It was like almost like an emerald or something. And this is a skunk. And I found this at Telluride. No, not a skunk. I'm sorry. This is a porcupine. And it was ridiculously beautiful. It looked like an electric blue pincushion. Just every quill was lighting up in the ultraviolet light. And here is Monotropa uniflora, the ghost pipe. So those look pretty cool. And here's an entoloma. So the entoloma glowing bright blue. A lot of entelomas do that. But a lot of mosses glow bright red. And the bright red is like this blood red color that's from the chlorophyll. So a lot of plants will fluoresce this bright red color. However, a lot of plants that have protection from the sun will not fluoresce. So if you're in the deep rainforest or even in the deep forest here in Oregon, there will be a lot of really cool fluorescent plants. Whereas if you go out into the desert where there's full sun, none of the plants will fluoresce at all. And that's because they all have protection from the ultraviolet light, and that stops your black light. Here is Cyptotrauma from New Zealand. And this one looks pretty similar in ultraviolet light and white light. And then here is a super rare psilocybe from southeastern Mexico. So this is Psilocybe hymii. And Psilocybe hymii glows a bright blue. And the mosses around it look really cool as well. And then Psilocybe subruginosa from New Zealand. A lot of the psilocybes have gill edges that light up really bright. So that's the row of Cheilocystidia on the gill edges. And then this is a Descolia from New Zealand. This was right from near the thermal, like the geothermal areas. So these were dangerous photos to take, but this one turned bright blue in ultraviolet light. And this is ectomycorrhiza with lithospermum. But then just 10 feet away, there were some more Descolia, and they looked exactly the same to me. But in black light, they glowed a bright yellow. So these ultraviolet lights are a really good chemical sensor, and there are thousands of fluorescent chemicals in nature. So you can get some insight into the chemicals in a mushroom that you can't get with just white light. They're also really good for morels. At the OMS camp this weekend, we had a whole big basket of morels, and you couldn't really tell which ones were different. But then with the ultraviolet light, it became really obvious which ones were different, and I was able to separate them out into different species. Here's one where my black velvet just fell down on the mushroom, and I was in the middle of taking it. So it got all messed up, but it still looked kind of cool. And then all this craziness is the lint that's on my black velvet. Here is some Paneolus cyanescens, an extremely strong psilocybin mushroom that I found in my friend's closet. And this one glows a bright yellow. And then Entosibe trichiaspora. This one's pretty common on the coast here. And you get a beautiful cobalt blue out of this. And then Entoloma subcarneum is also a very cool cobalt blue mushroom. And in ultraviolet light, it's even more blue. And what makes it blue are all these little droplets on it. So these droplets are just like ridiculously bright. They look almost like stars or something when you shine a black light on this. And then here's a spore print of it. And you can see the spores are just barely fluorescent, but I think there's just like dye from the mushroom just kind of like wicked into the spore print. And it's also pretty good for identifying Ganoderma. So here we have Ganoderma sugae with Ganoderma lobatum up at the top. And you can see they look way different in black light. The Ganoderma sugae almost looks like a really colorful world map. And then the lobatum is just always super blue. And then this mushroom is pretty cool. This is one of the rarest mushrooms on Earth. It's only found in one spot in the whole world, and that spot is only about 20 feet wide. And so Lepiota luteophila, it's extremely beautiful because these gills are just bright, bright yellow. But they're also extremely fluorescent. And so these things, they glow an extremely bright green. They're almost as bright as those Cortinarius, like Cortinarius clandestinus. Here is Mycena phylopes. This one's from Humboldt County, but same thing grows in Oregon here. And this is actually a new species. The real phylopes is all over the Midwest and the East Coast in Europe, but our one on the West Coast is a different species. But this Mycena is super easy to identify because it has a really unusual smell. It smells kind of like mothballs or iodine. Another super common, super common but rarely seen Mycena around here is Mycena tenerama. And so this one is always extremely tiny. The really large cap is like a centimeter across, usually smaller, but it always has this really big expanded foot here. So if you see this disc at the base of a tiny white Mycena, it's this one. And it looks pretty cool in ultraviolet light. And I've recently been told that this one is also bioluminescent. So I found this in the middle of the day and just used some black velvet to give myself a little bit of shade to take this picture. But I'd really like to try again with a long exposure and see if I can get it to glow as well. There's also another one that grows on the coast, and I got pictures of it at, where was it? It was like Ecola State Park. And that one was Mycena, I call it like Mycena quinaltensis. And that one is bioluminescent and fluorescent. So the stem bases, they glow like a bright gold in ultraviolet, and they glow green in just in complete darkness. That one I have not finished my pictures of yet, but you'll definitely see it out. It's a really unusual Mycena. And here's Entoloma bicoloripes, and that gives us a beautiful blue color. And then one of the most common entolomas in the mountains in the spring is Entoloma holoconiotum. And this one gives us a really bright sea green color. We saw a whole lot of that this weekend. Porodadelia pini is a polypore that loves killing trees. So I think I've heard that it's like the one that kills more trees than any other mushroom, but it is beautiful in the black light as well. And then this one is one of the Cortinarius from subgenus Leprosebe. So we have about a dozen Leprosebes on the West Coast. This is our coastal one. And so in white light, it looks just like a regular plain old Cortinarius. You wouldn't expect it to do anything crazy, but it glows really bright. Like you can see it from 100 meters away. There's hardly anything else that glows quite this bright, like maybe scorpions. Those really light up. So this is one that just got named a couple years ago by Dimitar, Cortinarius fuscoflavidus. And then pseudobiosporas are one of my favorite mushrooms to hunt because they're really mysterious. They love cypress duff, which you can see here. There's a whole lot of species. And this one kind of gives us a blue color in ultraviolet. And then out east, you have Pseudoboletus parasiticus. So this is a bolete that fruits from an earth ball, the scleroderma. And that looks pretty cool in ultraviolet light as well. Rhodophana is a really mysterious genus because it's in the Entoloma family. But there's like 6 different species on the West Coast and none of them have names. It also smells terrible, like burnt rubber, and it's super brightly fluorescent. And this is kind of cool because the bottom is blue and then it's more like sea green up at the top. And then russulas are some of the most fluorescent mushrooms. So if you shine a black light at the russula section at a fungus fair, they will all light up, but differently. So if you go to a fungus fair and there's a whole basket and they say, oh, this is Russula rhodocephala or whatever, if you shine your black light on it, you can easily see like that they have different species of Russula mixed in there. So it's a really good way to separate these things. But this is just a really boring Russula photo. And there was just one of them, so I wanted to make it cool, so I shined the black light on it and turned a really boring photo into a pretty cool one. Here's another Russula. This one's from Michigan. And one that we have a lot of in Oregon here, Russula zelleri. So these Russula that have the kind of wine-colored purple caps almost always have an electric blue color in ultraviolet light. Here is Tilichildium brachiatum, and this is a picture I took on the Oregon coast. So it's a really cool parasitic fungus and looks really cool in black light as well. And then Entoloma styrophorum is from Ecuador. It's really cool, super acute umbo on it, and these glow bright blue. And here's a slime mold. Most slime molds don't do anything in ultraviolet light, but this Badhamia looks pretty cool. It's like the things that hold, looks like clusters of grapes being held up or something. And the cords fluoresce pretty well. Here's one that I took really close to here in Amboy, Washington, so just over the border, with the Chimenophyllum. And it's just a white mushroom, but in UV light, it glows super bright blue. And then here is one, Tricoloma aurantia olivaceum. This one I did something a little bit different in that I opened up the shutter for 12 seconds, and then I used the ultraviolet light and shined it on the top of one of them for 6 seconds and on the top of the other one for 6 seconds. So it kind of looks like they're glowing from inside. And here is a Galerina, like Galerina vitiformis type thing. And here is our Bovista from Colorado. So this is at the Telluride Mushroom Festival. I think I'm teaching a mushroom photography class this year at Telluride. So good festival to go to. But yeah, these Bovistas are really cool because when you find them, they glow bright blue, and then you cut them open, and they're bright green. And then Schizophyllum communi is a really cool one. They call it the split gill. But you get a really bright blue color out of it. And then here is Psilocybe subtropicalis, really strong psilocybin mushrooms from southeastern Mexico, and looks really cool in the black light as well. Here is Luridiomyces squamosus, and so this one's from West Virginia. And you get these really strongly fluorescent gill edges. And here's some armillaria that I found in Amsterdam. And this is covered in this, this algae. So the algae has chlorophyll and it lights up red. So it ends up making it look really cool. Here's some Cordyceps militaris that Ryan Paul Gates cultivated. And that looks really cool in black light too. This is cultivated on some rice. And there we are taking the pictures. That's at a mushroom festival called MycoFest that William Padilla Brown puts on. It's a really good festival in Pennsylvania. Selaginella is a lineage of ancient giant mosses, and they look really cool in ultraviolet. So you can see here those waxes that protect it from the ultraviolet, and then in the freshly growing tips, there's no protection from the ultraviolet, so you can see the chlorophyll fluoresce. Here's Calorhiza umbonata, the redwood rooter, and this one's really unique because the old ones fluoresce kind of sea green, and the young ones of the same species fluoresce bright blue. Here's Viola glabella, the stream violet. You'll see these in kind of really shaded areas, and they fluoresce bright blue. Here is a poison hemlock, Conium maculatum. So if you eat these, you'll die in about 15 minutes. But the flowers are really pretty in ultraviolet light. And here is a spruce. The freshly growing tips fluoresce blue, and then the older parts fluoresce green. And this one is super cool and rare. It's a new species, so it has not been named, and then it's a new genus. So the genus has not been described yet either. But in the book Mushrooms of the Redwood Coast, they call it Albogymnopolis nanus. And it's really unusual because I sequenced the DNA of it, and it came out like right next to Gymnopolis, but it has a really viscid cap. So all of the Gymnopolis have dry caps, and this one has the really slimy cap. And it's super fragile like a tuberia, and it's super fluorescent. So these are another one that you can find at a really long distance. And then it looks really different when you put potassium hydroxide on it. So these are the parts that I added KOH. It turns bright green. Here is a blue chanterelle from Mount Hood. And they get a beautiful cobalt blue color. And then here's something kind of mysterious. This is a leaf with little spots, and the spots light up extremely brightly, orange, and I can't figure out what's causing it, but you can see the spots just a little bit like this. But when I take these spots and cut up a little bit and throw it under a microscope, there isn't really anything obvious different about it. Sometimes they're orange, sometimes they're yellow. And so I took these pictures in Michigan, but I've seen the same thing on the Washington coast as well. Here's a Foliota. And here's a Hemimycena. It's probably undescribed. So this is the one that we call Hemimycena species California 10. And so it's been DNA sequenced, and whenever we DNA sequence something and we can't figure out what it is, we give it a code name. And that's really useful because that way at least we have a name to call something by. But it fluoresces a nice bright blue. One of the most common fluorescent mushrooms, and also one of the brightest, is sulfur tuft. And so this one is from the Washington coast. And here on this leaf, you can see that mysterious orange stuff. And then you can also use a fluorescence microscope. So this is a little bit of sulfur tuft gill with a Zeiss fluorescence microscope. And so this is the lamellar trema, the inside of the gill there. So that's glowing a really bright yellow. And then this is all of the basidia, and those are glowing a really bright green. And you can convert any microscope to a fluorescence microscope just by either shining a light down onto the sample or just by putting a really bright LED where the microscope light would go. Pretty much all of the hyphilomas are really cool in ultraviolet light. This is the late iridium, and that gives us a nice blue color. I don't have the Hyphiloma marginatum in this talk, but I got some pictures of that in Washington, and it's really beautiful too. This one's kind of cool, Colibia cookii, and colibias make these sclerotia. So these are all little sclerotias here. And you can see that the mushrooms fluoresce bright blue, and the sclerotia fluoresce more of an aqua color. These are ones that I found in Telluride, but they grow around here too. And most cultricias do not fluoresce at all. But cultricias are super mysterious because we've borrowed European names for all of them, so we don't really have any names for our cultricias in North America. And this particular one I found in Pennsylvania, and it was fluorescing blue. But when I first took this picture, I was like, oh wow, cultricia fluoresces. But then I started checking all the other cultricias, and I have not found another cultricia that fluoresces since. So there's a lot of species out there. It's kind of interesting that not all of it fluoresces, but just some of it. And then here's a millipede from Texas. And this one was really cool because the legs light up super bright. So you can imagine what it would have looked like when it was walking. There's a bunch of different millipedes that light up really well. And then, of course, scorpions light up really well. And so you always get this bright blue color out of scorpions. And you can always tell if there's scorpions in the area, even if you don't see any, because the scorpion, I don't know how long it lives, maybe a year or something, but then it breaks up into little bits, and the bits are super fluorescent. So if you're just like in an area with scorpions, you'll see like little scorpion pieces that are really persistent. And there's a porcupine. And then there are a lot of fluorescent lichens. So on this stick, there's like 6 different kinds of lichens. There's that one, and that one, and that one, and that one. There's like a whole bunch of different ones. But in ultraviolet, all of a sudden, you can tell them apart really easily. So Pyxine subcinerea is one of the brightest lichens. And it's really common. You'll see it around. But this one here fluoresces, but just barely, kind of gives you an orange color. But you can see in white light, it looks really similar. And then Xanthoria periotina. This is a really cool lichen, and this is one of the ones that Sydney Obersingleton has been studying. If you follow him on social media, you see all his posts about it recently. If you don't follow him, you should, because he posts really cool stuff. But in UV, you get these really nice colors. Another one that I took on the Oregon coast is this Ochrolechia. And so kind of cool because it's like orange spray paint almost. And it's like bright gold. And then Achirospora is one of the most common lichens on rocks. And this is with 395 nanometer blacklight. And this is with 365. So the party blacklights are 395. And you get a whole lot of purple in your photos. And things don't light up nearly as well. So I always recommend people get the 365 blacklights. They're about 100 times better for walking around the woods at night with. Here is a Spherospora. And so these lichens are pretty cool because they look like jellyfish or something. We were seeing a bunch of these at the OMS camp this weekend. But you get a really nice blue color out of them. And here's some Usnea. They light up a little bit, not quite as much though. A bunch of different lichens together. And this is just about the last one I have, but this I found at Mount Rainier. And in white light, it was like a polypore that had these pink spots on it. And then in ultraviolet, the pink spots lit up really bright. So this is pink bacteria. So this would be kind of a cool thing to culture and get it going on agar. Definitely lipstick colored. And here I am photographing some stuff at night. And so for photographing ultraviolet stuff, it's 1,000 times easier than photographing bioluminescent stuff. But there's still a few things to think about. So definitely you want that 365 light and not the 395 light. And you want a really bright one because a lot of the really cheap 365 lights are really dim. But the really bright one, I paid $120 for, but now you can get the exact same one for $30 on Amazon. I'll give you the link for that in a minute. But it doesn't have to be super dark. Like I can do fluorescent photos in the middle of the day, especially if I just kind of like cover something with my backpack or some black velvet. And then about like 3 p.m., if it's down in a gully, I'll start taking UV photos, or 4 p.m. if I'm up on a ridge top. So even if there's a pretty good amount of sunlight around, you can still get really good fluorescent photos because a lot of this stuff fluoresces really brightly. And I usually use a tripod so I can do a long exposure. And what I do is I I turn on a bunch of LED lights and then focus and take my photos with white lights. And then I turn on the manual focus so it doesn't have to hunt for the focus at night, because once you turn the LED lights off, the camera won't be able to autofocus anymore. And so it's already focused, and I turn on like a 5-second delay. So when I press the shutter button, it's not going to shake the camera. And then I'll do like maybe a 3 or 4 second exposure, maybe ISO 400, f22. And so the shutter's open for like 4 seconds. And what I'll do is I'll move the black light in an arc over the camera lens. And that way the light comes from all different directions and you don't get any harsh shadows. Also, I like to kind of paint with the light. So if there's a part that's really brightly fluorescent, I'll kind of avoid that part and then kind of shine the light a little bit longer at the dimmer parts. That way there's not like the really bright parts don't get blown out. So here's just a little bit about the electromagnetic spectrum. The stuff over here is really high energy and really dangerous. And then here's visible light. And then the stuff here is really low energy and really safe. So your cell phones are around here. And then within the visible spectrum, the IR is invisible, but that's where you get the heat. And then this is like the safest kind of light. And then as you start getting into blue and purple light, it gets a little bit more dangerous, but not very dangerous. So 395 is like right about in there. And then the 365, the really good lights, they're over in there, just outside of where your eye can see. And those are a little bit dangerous, but not too bad. The really dangerous ultraviolet lights are over here, the 250s. And that's what they use for like killing germs, or sometimes they use them in rock hounds, like for hunting rocks. But I got one of those. It was a 1 watt LED with 265 nanometer. And that one's really dangerous. And so to use it, I have to put on sunscreen and also glasses, because it'll give you sunburn and skin cancer really fast. But it turns out that that wavelength does not excite very many things in nature. So it's not really worthwhile. And the 365 is a whole lot better. So a really good ultraviolet light is this one up here. And so I think I have one of those around here. Is they do not come with a battery, so you got to order the battery separately. But you can see that this 365, they're like a little bit blue. And let's see, let me flip back. We go out of the presenter, maybe. Yeah. Yeah, so this light, $30, but then you got to buy the battery and the charger, but still, really nice light. And one thing you'll notice about the really good ultraviolet lights is that they look black on the front, and that's because they have a filter. It's called a ZWB2 filter. And what this filter does is it blocks all of the visible light, and it lets ultraviolet through. So the LEDs in here, they make some aqua colored light, and you don't want the aqua colored light in your photos. So by having this filter, they block that, and you just get pure ultraviolet out of it. And these things are really fun to walk around with at night. So also, if you like glowing things, this Facebook group, Fluorescent Forest, is really good. It's just all about glowing photos. And there's a lot of cool people on there that post a lot of beautiful photography. And then they have this awesome iNaturalist project called UV fluorescent organisms. And this project, you can add your ultraviolet photos to this project, and then it documents what is fluorescent. I think I have that in one of my windows here. Yep, so this is the UV fluorescent organisms project. So you can see that we found 2,600 species are fluorescent. And you can see the people that are finding the most of these. And Damon Tai is always at the top of the list. Super cool guy, lives pretty near me in California. And then Michelle Wong is also super cool. She lives in Texas, and she's an amazing ultraviolet photographer. And you can also like go in here, and if you want to see if something has ever been found to be fluorescent, you can just like search in here and see, see if it's been documented before. But like scientists are always publishing like, scientific papers like, oh, we discovered a new fluorescent animal. But actually, we're like kind of discovering new fluorescent stuff all the time, and it's pretty easy. But if we like zoom in around here, we can see like what's fluorescent around here. And here's like a sulfur tuft and polypores, all sorts of stuff. Oh, this is cool, a nice fluorescent ghost pipe. Oh yeah, it sure is. Very cool. But there's also a bioluminescent organisms project, so that's where you can like track all of your glowing mycenas and stuff. And that is all I have for you. Yes. That's a really good question. It was, is there any evolutionary benefit for bioluminescence? And the answer is really probably, but it's really hard to be sure. It probably attracts insects. So, having wind disperse the spores is not a very efficient way to do it. If you can get insects to move the spores and mycelium around, then the insects can move a lot of spores at once. And also the insects will kind of be drawn to like the similar kinds of substrates. So maybe they'll bore into a tree and give the mushroom like the first advantage over in that tree. So my guess is that it's for attracting insects. But also, some people have theorized that when these bioluminescent mushrooms release a photon of light, it takes a molecule of oxygen to do that. So it could also be an antioxidant. And the other thing that people always ask me is there an evolutionary reason or benefit for fluorescence? And I'm pretty sure the answer to that is no, because there's no pure sources of ultraviolet in nature. We have like tons of ultraviolet from the sun, but you have so much white light at the same time. So I think with this fluorescent stuff, it's just a byproduct of all of the crazy chemicals that we have in our mushrooms. Yep.
You had a mycena, and you said it's bright enough to like read a book.
Yeah.
Is there an intersection of like furniture and fluorescent fungi or bioluminescent fungi? Is that a thing, or do you foresee that being?
A lot of people would like to do that, but I don't think it's super practical because they only glow when they're fresh. And so, some of the mycelium glows, but it's pretty dim. The fruit bodies can be a whole lot brighter. So you could read a book for a little bit, but the mushrooms are kind of small and they would dry out pretty quickly. So I don't think it's super practical. They did just start selling genetically engineered fluorescent petunias, and they took the genes out of fungi and put them into petunias, and they're actually pretty bright. Like they're pretty good. I don't know if you can read a book with them or not. I haven't gotten my hands on one yet, but I don't think it'll ever really replace streetlights or anything like that. Like these bioluminescent mushrooms, you can definitely see them at night, but then if you're in a city with like all sorts of lights around, you can't really see them anymore. You kind of need like a really dark night to see most of them. Yeah, Sydney ordered the petunias. Maybe if we're really nice, they'll give us cuttings. Mm-hmm. So the focus stacking software that I use is called Helicon Focus. And it costs money, but there's a 30-day fully functional free trial. And the other really good focus stacking software is called Zerine Stacker. And so what I always tell people to do is download Helicon use it for 30 days. And then once it expires, download Zareen and use that for 30 days. And then whichever one you like better, then you can buy if you're still focus stacking after 60 days. But with focus stacking, you're kind of like bending the laws of physics. So it's a really cool thing to do. And you don't really need one of these really fancy, expensive cameras to do the focus stacking. A high-end camera can take a picture and then change the focus and take another picture and do that automatically. But you can do the same thing just by taking a picture and changing the focus on your lens and just take the stack that way, or by moving the camera slowly closer to the object. Or with a cell phone, you just touch on the tap on the closest mushroom, take a picture, tap on the middle mushroom, take a picture, tap on the furthest mushroom, and then just load those cell phone images into Helicon and stack that way. But the smaller the mushroom is, the more important it is to use focus stacking. So if it's a really big mushroom, I might only stack 1 or 2 images. Or if it's a really tiny mycena, I might stack like 120. Yep. For which ones? Oh, yeah, that one. So that one, I was basically just shining a really bright light down, and it happened to be an ultraviolet light, but you could use any kind of light, and just shining a light down through the top of the mushroom. So, the camera was kind of like underneath the mushroom. So, the mushroom appeared to be glowing. But there's a bunch of photographers that do that these days, and it ends up looking really cool. And what they do is they just have like little tiny LED lights, and they put them in different places. It's kind of like those little keychain lights. And you can put them under the mushroom. You can put them inside mushrooms if it's like a big amanita or something. There's all sorts of places that you can put little lights and kind of light them up from the inside. Yep. Most of these chemicals in mushrooms are pretty mysterious, and especially the fluorescent chemicals are pretty mysterious. So most of them are unknown. Like in sulfur tuft, it's the same molecules that make them poisonous are the ones that are fluorescent. And for a few of them, there's like papers about the chemistry, but most of them, we don't really know as much about the chemistry as we should, and there's just a lot to be discovered there. Recently, they had a paper where they put psilocybe cubensis into a GCMS, and they found over 1,000 peaks coming out. So there's like 1,000 different chemicals in just this one mushroom. And I think most mushrooms will be the same way, in that you just have so many different interesting chemicals in there. And a lot of them are chemicals that we have never seen before, but they're, so they have no name yet, but they're really likely to be chemicals that have, beneficial properties or interactions with humans, just because, they're in fungi, and the fungi are sort of vaguely related to humans, closer than plants. And so a lot of these chemicals are not random, but chemicals that have some sort of use, or did have some sort of use a long time ago. Yep. Let's see, yeah, that was a really cool one. And I'm not exactly sure why the bugs make it fluorescent, but I think there's definitely the chemical called berberine in there. And so the berberine is fluorescent. It might be like an insecticide chemical, or maybe it's just in the leaf and we just can't see it because the leaf has like, ultraviolet protection on there. But that plant has a lot of uses. It's been used by the Native Americans for a really long time. And I think I think that berberine is also like used as a supplement by a lot of people, and so it's a very heavily used plant, and really interesting chemical. But I'm not exactly sure why it makes it, or why it's only visible where the bugs were biting. But when I saw it, I was just like blown away with how beautiful it was. And that leaf was tiny; it was like half an inch across, just a little tiny thing. But I saw it, I'm like, oh wow, this is going to be a really good picture. Yep. Yeah, I can sell these as prints. And so I put all of these up on iNaturalist and Mushroom Observer. iNaturalist reduces all of the images down to 2000 pixels, whereas Mushroom Observer allows me to upload the full resolution thing. So if it's a mushroom photo, you could just download the original size image from Mushroom Observer and then just print it. All of my photos come with a free license, which means anybody can use them for anything forever, even selling them. So you don't have to give me money. But if you want to order prints, I can just have them made and shipped. And that works too. But either way, I like to do it. I like to go to this place called Bay Photo. And they're in California, but you just upload a really high resolution JPEG to Bay Photo, and then they will print it and send it to you. And you can do it on a million different things. You can do it on acrylic or fabric or wood, but I usually order it on aluminum because the aluminum, it looks really good printed on aluminum. It's nice and sturdy, and then you don't need to frame it. You can just hang it on your wall. And it's actually cheaper to order an aluminum print than it is to order, like a paper print and then have it framed.
If you did have to name the picture that you dropped, the black velvet, and it was like the mushroom.
That's a really good question. See, I don't know what mushroom it is yet. I was taking that photo so I could have like a documentation of the ultraviolet reaction. And then I saved the mushrooms. So I'm going to send it to Stephen Russell for DNA barcoding. But yeah, I'm not sure what the best name is for it, but it's super trippy. And it's like one of my most popular photos ever. So it definitely deserves a good name. Yep.
So with the phosphorescent ones, they would look different, wouldn't they, to like an insect that's ultraviolet? And is that a reason why they have the phosphorescent?
Well, I think the word you're looking for is fluorescent, because phosphorescent is when it keeps glowing after a while. But yeah, for the fluorescent things, see, it's kind of like there are insects that can see ultraviolet, but what we're seeing is not the ultraviolet, but just that the ultraviolet light excites these molecules and then they give off visible light. So if just because you can see ultraviolet doesn't really mean that the fluorescent mushroom is going to look any different. It's just like more wavelengths of light that they can see. So things that are fluorescent do look a little bit brighter. And like that's how fabric softeners work, whereas they make all of your clothes a little bit fluorescent. So it converts the ultraviolet from the sun into white light, and then your clothes look brighter and cleaner. It's just because there's so much white light whenever there's ultraviolet light coming from the sun. I can't imagine that the fluorescence is really ever visible to anyone that doesn't have a black light. And so I think that there's no evolutionary reason for them to be fluorescent, but there can definitely be evolutionary reasons to have fluorescent chemicals, but it's just the other properties of the chemicals that they're using, and the fluorescence is just kind of a side benefit that looks really cool and helps us detect that the chemical is there. But fluorescent chemicals are super common. They're like everywhere in nature. And probably about like 10% of organisms in nature are fluorescent. Like some spiders, like the crab spiders, are super beautiful. Those are really cool. And like so many like insects, like my dog is fluorescent. The platypus is fluorescent. A lot of like possums are like fluorescent, bright pink. So there's a lot of different fluorescent chemicals in nature. And I'm sure some of them confer benefit, but not the fluorescence part of it, just other things that the chemicals do. Yep. Yeah, let's do that. We'll finish here and just like shine the light on the table and see if anything lights up.
Thank you.
Thanks. Thanks. So these are giving us a little bit of an aqua color. That's the infundibulus be. No, I've heard it's really good though. Yeah, I would definitely try it. The pseudo-omphalina is lighting up a little bit. So here you can definitely see we have different morels. So this morel is giving us kind of purple all over it, and this one is more like sea green. So definitely two different kinds of morels.
Is this tomatosa? Or is it a bird?
I guess so.
The spike is so light.
It is, yeah. It's kind of hard to tell. I think it's got to be tomentosa, though. That's cool. I've never seen tomentosa in UV before. And this inocebi, we're getting some like green in there, especially the gill edges. And, oh, these are cool.
Oh, yeah.
Yeah, so these things light up pretty good, but they're even better. Cut them open. Here's one. Hold that. There's one cut open. Yeah, cryptoporous. And so, yeah, the fresh ones are the best. But yeah, you get a nice pink color out of them, and then kind of like this other color on the outside. Yeah, cryptoporous are always really good.
These are my favorite mushrooms.
Yeah, they're great.
It's just so fun.
And these morels, I think these are the morels that we found today.
Yeah.
And so they're a nice purple color, and then it's like the inside looks pretty cool too. It's interesting how like the very middle like isn't fluorescent really at all. But the stem is fluorescent, so it's interesting how the outside of the stem is fluorescent, but the inside, like the very middle, is not really doing much at all. Definitely have to document them more. Oh, these glow pretty good. That's pretty cool. And the Milano Luca is a little bit. Sarsaparilla veil is lighting up. Let's see down here.